Hello, hello all my physics maniacs. What I'm trying to accomplish today is I'm just looking at Coulomb's law and how I can use it to look at the interaction between two things. What I have here is I have a charged pith ball right here. Pith ball is, remember that's graphite coating around just a styrofoam ball. And then here I have just a charged plastic rod. I've already charged it. Maybe I rubbed it on some fur or something, but that's already been done. And we can see that that gave it 3.125 times 10 to the 13 more electrons than it has protons by that process where I rubbed it on some fur. So I'm looking for how much charge the pith ball has by having measured what force they pushed each other with, or sorry, they didn't push, they pulled each other. I can tell because I used the word attract there. And they're 5 centimeters apart, so I know that what I could do is using this amount of force and this 5 centimeter distance between them, I could look at that relationship with Coulomb's law. Coulomb's law is the one that tells me that the electric force between two charges is equal to that constant K. Remember, that's 9 times 10 to the 9. The unit there would be newtons times meters squared over coulombs squared, times the charge of one object, so say times the charge of the pith ball, times the charge of the other object. The other object would be that charged rod, and I'm dividing that by how far apart they are squared. So looking again at what I have to work with here, I do know that that force is 0.36 newtons, and I also know that the distance that they are apart from each other is 5 centimeters. Although before I go much further, we should also recognize that 5 centimeters isn't going to work out for us. We're going to need to convert that into meters by the time we actually want to start working with numbers. Now, this number k here is just constant. It's that 9 times 10 to the 9 number. So I know everything except for the charges of these two things. Now, if I wanted to know the charge of the pith ball, if this is the variable that I'm looking for, then before I can actually solve this, then I'm going to definitely need to figure out what the charge on that rod is. So let's stop our work with Coulomb's law for the moment, and let's just take a look at how I can use this number to figure out what the charge is on that rod. We do know how much charge one single electron has, and so basically I can just do what amounts to a unit conversion to figure that out. So the charge on the rod is equal to, I'll just take how many electrons I have and multiply it by the charge of a single electron. And I know that the charge, or I know that the number of electrons is 3.125 times 10 to the 13 electrons. And I didn't plan this out very well. I'm just going to move this over. And I need to multiply that by how many coulombs there are for every one electron. And then we'll notice that I'm going to end up dividing out here, and I'll just be left with number of coulombs for my answer. And the number of coulombs that one electron is would be negative. Remember, of course, electrons are negatively charged. 1.6 times 10, and again, poor planning on my part, times 10 to the negative 19 coulombs. So I just need to do this multiplication. Now I'm multiplying what is a very large number of electrons times a very, very tiny number of coulombs for one single electron. When I do that, though, I'll get the number of coulombs for that large number of electrons. And when I do that math, then I come out with a nice, neat number. I get 5 times 10 to the negative 6 coulombs. That's 5 millionths of a coulomb. That's 5 microcoulombs, which I could do that if I really wanted to put that much charge on a plastic rod. So now I know how much charge fits onto, or how much charge is on that rod. So now I know every one of these numbers in my equation except for the charge on the pith ball. So now I'm ready to get into that business. Although before I do, since I'm going to be solving ultimately for this number right here, it would do me some good to do a little bit of algebra first. I think what I want to do right now is I'm just going to multiply this r squared over to the other side of the equation before I go any further. I'm going to have to get that q all by itself, so might as well move that r over sooner rather than later. So I've got that electric force times r squared is equal to that constant times the charge of the pith ball times the charge of the rod. Now I know every number except for the charge on the pith ball. I know that the force was 0.36 newtons. That distance that they were apart was 5 centimeters. I want to put that in meters. That's 0.05 meters. That gets squared. That constant is 9 times 10 to the 9. Unit is newtons times meters squared over coulomb squared. As we'll see in just a minute, that's the unit that we need to make Coulomb's law work out when I'm using coulombs as my unit of charge, meters as my unit of distance, newtons as my unit of force. So that times the charge of the pith ball times the charge on the rod and it just occurred to me that I made just the error of that should have been a negative number all along, although the way that I tend to work with Coulomb's law, this was a negative number because it's extra electrons, and electrons of course are negatively charged. But the way that I tend to work with Coulomb's law is I just think in terms of absolute values on charges, so that I'll just use my brain to decide what direction is the force, knowing whether we're attracting or whether we're repelling. So I'll let my brain do that business, and I'm just going to work right here with the absolute value of that amount. And then we'll think about the direction shortly after. Anyway, you can also see, if you look closely, if we look at the units, I've got newtons and newtons on the left and on the right, and here I've got meters getting squared and meters squared. I've got coulombs and coulombs, and you can see that all of the units divide out except for this one coulomb, which is in a denominator. When I move it over to the left side though, then I'm going to be able to get an amount of charge in coulombs. I'm just pointing this out so that we can see that yes, the units do actually work here and will give me a charge in coulombs. Anyway, to get this charge then on the pith ball, then I just need to divide the numbers on the right over to the other side. So I'm going to be left with 0.36 times 0.05 squared. I already divided out the units, so I might as well just keep it that way. Divided by 9 times 10 to the 9 times 5 times 10 to the negative 6th power. And I had coulombs in the denominator of this 9 times 10 to the 9 number, so when I put that in a denominator, I'm just going to be left with coulombs. Now I can put those things in my calculator, and 0.36 times 0.05 squared divided by the product of those two numbers in parentheses. Now if you're working this out, do be careful with the way you type that into your calculator. Make sure that the way you're typing it in your calculator is actually dividing by the product of those numbers and not just typing in to divide by one then multiply by the other. And when I do that, then I find that the charge on the pith ball is 2 times 10 to the negative 8 coulombs. So that's the absolute value, at least, of that charge. But what about its sign? Now, if we think back up here, we see that we are attracting. So I've got an attracting force pulling the pith ball and the plastic rod towards one another. And I know that it's opposite charges that are going to pull on each other. And knowing that the plastic rod is negatively charged, well, then the pith ball has to have the opposite sign of charge. So the pith ball has to have a positive charge. And there we go. So thanks for playing, and I will see you sometime soon. Take care.